Hello, today we will solve a problem to find the permutations of a given string. Let's have an example of a string. Okay, just a sec. A string I'll call text A, B, and C. And we will consider this code. Here we find recursively all the permutations of a given string ABC. So this function gets as a parameter the text itself, left and right pointers, and the permutations vector where we store all the permutations of the given string. And initially we have a left pointer, which is an L, a 0, and a right pointer will always be the last index of a given string. In our case, we have 0, 1, and 2, so R will be 2. And for the recursive part, recursive calls of the function, I will use the stack, and the loop part will be, I will write the loop part here, but we will have a look at this now. So firstly, the text ABC is passed with values L0, let's say L equals to 0, and I, also there is this value I, which always be equal to L whenever we call the function initially. So I will equal to 0 and R will always will equal to 2. So the text is ABC. And then we swap the text L and I, and when the function is called, L and I will always equal to itself, to each other, so we kind of swap A with A. And then we call the function recursively. So we are not going to this second part where there is a swap, but we are in this permute function call recursive part of the code. So we increment L, and I will always be equal to L whenever we call a function, and R is always 2. And the text remains same. We kind of swap B with B now, and then we recursively call the function with incremented L and R, so it will be ABC. We let's say swap C with C, and now we see that L is equal to R. This base case is true, so we say let's have this result array here, and we pushed A, B, C to our result, and we return. So we return from this level and go one back down, where L was 1 and I was 1. And now we return from this recursive part, and we can access this swap second part of the code, where we swap it back, these two values back, but L equal to 1, I equal to 1, so we kind of swap back B with B, so it doesn't change anything. And then we see the loop here. So now I will start incrementing, but this is not part of the recursion, so I will write it here. L is equal to 1, and I is incremented to 1 in the loop, so I will be 2, and R will remain 2. And we swap L and R, and our text is ABC, so we swap B with C, and we get A, C, B. And we call the function recursively again, so with incremented L, and L is 1, incremented by 1, so it will be L2, I2, R2, and the past text is A, C, B. And then we recursively call it again, where L is no, we don't call it recursively, not yet, since L is equal to R, so the base case works, and we push ACB to our result, ACB, and this one returns. So we go back again, and we see that I has been reached to 2, and we try to increment it to 3 in a loop, but it doesn't work, so we return from this level as well. And we go one back down, where we see that L is equal to 0, I is equal to 0 as well. So we return from this recursive part, and we access this second part where we swap the values back, but L equal to 0 and I is equal to 0, so we are operating on the same character. And now we start incrementing I, but it's not a like recursion, so I write here L is 0, I equals to 1, and R is equal to 2. and then we swap the text, and text right now is ABC, and if we swap L0 and I1, it will be BAC, and we call the function recursively, so we say BAC L1 I1 R2, so L was 0, and we call the function with increment L, so it will be L1, and whenever we call the function, we set I to L, so L1, I1, and R2, and we swap L1 and text I, so this A has been swapped with itself, and then we call the function recursively again with incremented L, and I is equal to 2, R is equal to 2, and the past text is BAC, and we see that L is equal to R, so we push this text to our result, so it will be BAC. And we return. We go one back down. And now we can see that, so we return from this recursive part, and we see that I is equal to 1. So what we do is we increment I, so it will be L1, I2, and R2. So we are now considering the loop part, so I is increment 2, and if we swap text L and text I, so it will be, our text currently is BAC, and if we swap 1 and 2 indexes, it will be BCA, and we recursively call the function, so it will be so it will be BCA and L1, L2, R2, and I2, and we see that L equals to R, so we push that to our result, BCA. And we go back, and we see that I has reached the maximum possible value, so we return from this level, and we are back here, and we considered the part where so in this part, L equal to 0 and I equal to 0, but then we increment I, so we were in a loop, and we still can increment I to 1 more, so let's say L is 0, I is 2, and R is 2. And then we swap, the text is ABC, we swap L0 and with I2, so A will be swapped with C, and we recursively call the function, so it will CBA with values L1. Since L is 0, we increment L by 1, so L1, R2, and I2, and then we keep incrementing L to 2, I to 2, and R to 2 with CBA. And when L equal to R, we push that to our result, and we return. We go one back, and we see that I is 1 here, and the text is CBA. We still can increment I to 1 more value, since we are in a loop, now considering the loop, so it will be, so let's say we increment L is 1, R is 2, and I is 2, and the text is CBA, and if we swap C in this text, we swap indexes 1 and 2, since L is 1, I is 2, so we swap B and A, so it will be CAB, and we recursively call the function with L2, since our L is currently 1, we incremented it will be 2, R equal to 2, and I is equal to 2, and L is equal to R, so we push that to our CAB, to our result array. And this way, we returned from this level as well. It's been exhausted, and I reached to 2. So this level is also done. So we have our result array.